I'm Chris Chapman. I work at Adobe. I'm on the Adobe Fonts team. I've been at Adobe about 4 years. For about 13 years prior to that, I was working at Monotype, also on fonts and font-related software, and with Unicode. So I spent a lot of time working on fonts and text layout and shaping engines and things like that. And I met Jeanette at the recent Unicode conference and was telling her about this whole stack of fonts and shaping engines and layout engines and so on, and she thought it might be interesting for all of you, in part to give context to what happens after you get something into Unicode. So if you add a new script or a new character for a language to an existing script, what else has to happen for it to be usable? And people often say you need a font and a keyboard, and that's true. And I'm not going to talk about the keyboard part. I think you've heard about that already. I'm going to request to speak up. I'll try to talk a little louder. So anyway, so people often say you need a font and a keyboard, and that's true. And I think you've heard about keyboards already. And in any case, I'm not going to get into that side of it, but I will talk about fonts and the things that have to happen along with the font. So there's actually software, in some cases, software changes that need to happen to support new languages or new writing systems and new characters in existing writing systems for languages that are just now getting support in Unicode. So I have to apologize. My first few slides I think are a bit text heavy, and then after that I get into more illustrations of what I'm talking about. So bear with me for the first few. And I can dig into any of these topics more when we get to the questions part. So if you have questions, just let me know, and I'll be happy to dig further into any of these things. So with that, let me go ahead and get started. Oops, let me be on the right screen here. Okay, here we go. So if you get nothing else out of my talk today, I think one point I'd like you to take away, or sort of 2 points, is characters and glyphs are not the same thing, and the relationship is not necessarily one-to-one. And this is very important in terms of how characters for different writing systems are handled in fonts and in software. And I'll dig into this more as we go on. So I mentioned there's sort of what I call a stack. You have at the bottom the font, which contains the glyphs, and then the rasterizer, which draws them, and then the layer above that is a body engine for handling bidirectional text, and a shaping engine for getting the right glyphs in the right glyph positions. And then above that, the layout engine that kind of lays out the text on your screen. So as I mentioned just now, the layout engine is sort of the high-level part. It's like literally laying out a line, breaking the line at the margin. Maybe doing things like hyphenation and justification. If you have images, it'll flow around the images, handle getting from one column to the next. That's all the layout engine. The BiDi engine handles things like Arabic and Hebrew in conjunction with other like left-to-right scripts and languages like English and Greek and Russian and so on. Even if you're only doing Arabic or Hebrew, you still need a bidirectional engine because, for example, numbers are still going left to right while the letters are going right to left. So it's the BiDi engine that handles that reordering at the character level. Shaping engine is what gets you the right glyphs and the right glyph positions for these different scripts. So if you think of Arabic, for example, many of the letters join up, much like we do in cursive when we're writing the Latin letters. But with Arabic, it's required. They have to join up. It's not optional like cursive would be in, say, English. Likewise, in Indic scripts, like Devanagari used for Hindi and Marathi, the letters form conjuncts. So like if you wrote my name, Chris, you'd have several characters like Ka, Halant, Ra, Chota, E are several different characters in Unicode, but it forms one what's called a grapheme cluster for the Kr syllable. And so the piece of software that handles that is called the shaping engine, and it works in conjunction with tables and the fonts, which I'll get into in a bit. And to actually get those glyphs on your screen, there's a piece of software called the Rasterizer, which is essentially, conceptually, it's drawing an outline and filling it in. So that's because the fonts just store the outlines of the glyphs. I'll show examples of that. And then the rasterizer draws them. And finally, the font. You can think of it as basically a file with a bunch of tables in it. And those tables have things like the glyph outlines, a map of Unicode characters to the nominal glyph forms. Another table that gives you a mapping of the different kinds of glyph substitutions you need for different contexts, like those contexts I mentioned, or the joined up Arabic I mentioned. Also glyph position information, so for example, for positioning diacritics, various metrics like how wide is each glyph, what's the line spacing metrics, that kind of thing. And there's a lot more tables with a lot more information, but I'll focus on mostly this part. So some examples of these things in open source. If you're using any open source software, you're probably seeing some or all of these. Pango is a layout engine. FreeBD, I think it's how it's pronounced, is a BiDi engine that's open source. HarfBuzz is a shaping engine. We even use HarfBuzz in Adobe products now. And then FreeType is a rasterizer that's the part that's drawing the glyphs. And there are open source fonts as well. So Nodo is a very large family of fonts from Google that covers pretty much all the world's writing systems that have been encoded already. And they're continually adding to it. And then the Source family is an open source family from Adobe. And there's some overlap, like Source Han Sans and Source Han Serif are is a Chinese-Japanese Korean family of fonts from Adobe called Source Han, but then the Nodo Han family is really the same thing. We work with Google and we make minor changes to it for the Nodo family. So there's some overlap in those projects. So getting into the fonts now, as I mentioned, it's a bunch of tables, and realize this is a bit of an eye chart, but if you look down the left column, you'll see the tag names. This is sort of an abbreviated form that's used to identify each table. And then down the right column, there's what says common at the top. That's basically the English name of the table. So, for example, you'll see G sub on there as the glyph substitution table I was mentioning earlier, Gpaws, glyph positioning, that kind of thing. I'll dig into some of these more as we go along. So, as I mentioned, there's like all kinds of data. So, for example, there's a naming table, which is called name. And so this example comes from one of our Adobe fonts. This one's for Arabic. So you can see the family name is Adobe Arabic. This particular one was the regular weight of the font. It's got version information, copyright information, stuff like that. It has the designer's names, all that kind of thing. I mentioned metrics. So there's individual glyph metrics. There's also line metrics. So the layout engine uses this for literally adjusting the spacing on the document, the lines in the document. So there's a notion of a baseline and an ascender, descender, and a line gap. And there's actually 3 places that's stored in the font. There's 3 different kinds of ascender, descender, and line gaps. So here's 2 of them from a table called the OS2 table. You see S typo, ascender, descender, and line gap, and then US Win, ascent, and descent. So the US Win ones are specifically for Windows. The S typo ones are used in other environments. And then here's yet another set, which is in the HHEA table. So if you notice different line metrics in different platforms, this is why the font may have different values in each of those. Sometimes they're all set to be the same. So the line spacing is the same everywhere. Sometimes they're not. And you can see there's other metrics in here. So now one of the important tables from the point of this talk is the CMAP table, which is mapping characters, that is the Unicode number assigned to each letter, to glyphs. So if you think of all the glyphs in a font as just being set one after another in a long list, and you just count them out, so you have an index for each one. They may be in different places. So like the letter A may be the 5th glyph in one font, and it may be the 42nd glyph in another font, and it may be the 1000th glyph in yet another font. So the glyph index for any given character, any letter, could be different in any font. So this table is what gets us from the Unicode number to the glyph index. And so for this example, I just picked the exclamation mark. You can see, my pointer does work. Okay. So this 0021 is a hexadecimal number representing the letter in Unicode. That's the Unicode character. And then this GID 874 is the glyph index. And then this is the glyph's name, exclam, which is just short for exclamation mark. So now, if we look at the glyphs in the font, I'm not going to show you all, however many hundreds are in there, but I just got to that one section. You see they're numbered one after another. So all the punctuation in this particular font happens to be right around here, and the exclamation mark is the 874th one. And these glyphs are stored in a table in this particular font called the CFF table, or compact font format, which is one that we developed at Adobe and one we prefer to use. But there's another one called Glyph, G-L-Y-F. It's a similar kind of table for storing the actual outlines of the glyph. So as I say, it's an outline. So that exclamation mark, if we look in the actual data in the file, what we'd see is a bunch of numbers representing points. And those points describe an outline, which is this outline. And then it's the job of the rasterizer to then conceptually fill that in with ink and draw that on the screen. So that's that part. So now, when you're writing with different writing systems, one of the things that has to happen is that the software has to know what they are and be able to segment them. So like in this example, where I'm saying konnichiwa, folks, kiahale, using 3 different writing systems, the shaping engine has to figure out that the first section is hiragana, the second section is Latin, and the third section is Devanagari. And the little abbreviations below, you see like kana, Latin without the I, and Deva. Those are the tags used in the fonts, 4-letter tags to identify the scripts. How it does this is it uses a file from Unicode called scripts.txt, and here I've just picked out the ranges that were relevant for the example I just showed. So things like spaces and punctuation are considered common, so they're shared by all or most writing systems. Latin letters are considered Latin, Devanagari letters are considered Devanagari, and Hiragana letters are considered Hiragana. And so these numbers on the left here are again, those hexadecimal Unicode numbers for each letter, and the dot just indicates this is a range from like 0941 to 0948. So everything 942, 943, and so on is in that range. So the shaping engine uses the data from this file and says, okay, if you're in this range, you must be this script. And then for the common characters, if we go back to my example here, like the space and the full stop and the question mark, those are common characters. They just get connected with the adjacent script for that run. And then that run of kana gets shaped using a subtable in the font for kana, the one for Latin from a different subtable, and the one for Devanagari from yet another subtable. And I'll show more about that in a moment. So these script tags, Microsoft maintains a list of them. So the font format is called OpenType. There's a specification from Microsoft that's an industry standard. It's maintained by Microsoft. I've given the URL for this script tags list on the bottom, but if you go up a couple levels to the typography OpenType part, that's the full spec there. So each script gets mapped to these tags, like Adlam goes to ADLM, Batak to BATK, and so on. So if a new script gets introduced, this table needs to be updated. So that's something to keep in mind. So now getting into some of the tables in the font, the glyph substitution tables I mentioned earlier, it's used by the shaping engine to get the right glyph form for that writing system given the context that it's in, the script that you're using, the language that you're using. So here's an Arabic example. If you look up here, so I'm pulling this out of the G subtable, the script is Arabic. Right now I'm just using the default language, and I'll talk more about that shortly. There's different features. So in this case, the feature that I'm applying is called a required ligature feature. And the kind of lookup that I'm applying is called a lookup, it's called a ligature substitution. And here the writing direction is right to left, as it should be for Arabic. So what I have here is an initial lam and a final aleph. And this is not the way you would normally write this in Arabic. You would instead have this lovely ligature glyph. So this lookup in the font is saying, if you have initial lam and final aleph, replace them with the single glyph, which is this lam aleph ligature. So I mentioned grapheme clusters earlier. like I said, if you wrote my name Chris, you would have ka, halan, ra, chota, e all legate into the kri syllable cluster. It'd be like one unit of writing, essentially. So here's another example. Here I have kshetra. So it's got 4 characters for the first syllable, which is ka, halan, sha, e, which these 3, the ka, halan, sha, forms this ksha glyph, and this e forms this a matra on top of it. So this is essentially one unit of writing. And then here you have ta, halan, ra, which becomes this tra glyph. So these have also legated. And the shaping engine tags these. It figures like, okay, this is a consonant. This is what Unicode calls a virama, but I think in Hindi is called a halant consonant, and then a dependent vowel, another consonant, another halant, another consonant. So it uses that information to figure out, okay, these are pieces of the grapheme that I'm building up. And that information comes from this file called indicsyllabiccategory.txt, also from Unicode. So here again, we have on the left these Unicode ranges. So the hexadecimal number 915 all the way up to 939 would be a consonant in Devanagari. 941 to 948, these are dependent vowels. 940 is, again, what Unicode calls a virama and other people call halant. So if you add a new character, say to Devanagari for a minority language, or you're adding even a new script for any writing system, any index script, you would need to update this index syllabic category file to have that information, so the shaping engine would know, okay, these are the pieces that I'm putting together. And then there's another related file that's used for positional categories. So here I've written Hindi, and the chota e vowel, this is a short I vowel, goes before the ha. So this is ha, chota e, na, halant, da, and then bara e, which is a long I. So the chota e goes before the ha, but the bara e goes after the conjunct of the na and the da. So that information comes from their file. It tells it this one is left and this one is right. And that's this indic positional category.txt file, which just maps that character number to left and the other one to right. So this is another file that would need to be updated if you're adding, say, new letters to Devanagari, or new index scripts entirely, or new characters to any index script. This would need to be updated so the shaping engine would know what to do with those glyphs, those characters, when it's manipulating the glyphs. So moving on to languages, just as we have tags for the individual scripts, we also have tags for the different languages. And they tend to be similar to the ISO 639 standard, but there can be differences. So that's something to be aware of. So here's a table again, from Microsoft's site. This is their list of language tags. You can see these 3-letter tags tend to be the same as the ISO 639. And sometimes there's more than one ISO 639, so that you have to know which one to use for OpenType. And sometimes it's a completely different tag for historical reasons. That's just something to keep in mind. Like here, like AGW versus AHG, they're completely different, or AFR versus AAR. So you can't just uppercase this and get the right thing necessarily. So again, if you're adding support for a new language, this table would need to get updated with Microsoft. So this is separate from Unicode, but Microsoft works with the Unicode Consortium on these things. So how are these used? Well, let's suppose you want to write in Marathi and you want to write Lahan. If you just type that out and use the Unicodes and use the default language, which in this case would be for Hindi, you're going to get the wrong glyph for the la. But if you choose Marathi as the language, then you're going to get the right glyph. This is an example from InDesign, but this would work in any software that lets you choose the language in the software when you're doing your typesetting. The way that works is, again, through the GSub table. So here, instead of relying on the default language, I've explicitly chosen the language Marathi. And you can see that the sort of the nominal la glyph that's the default for Hindi gets replaced with this alternative form, which is the normal form for Marathi. And you'll see this for lots of languages and writing systems. So for example, if you have a font that supports Arabic, Farsi, and Urdu, or maybe Pashto, for example, the default language might give you the Arabic forms of everything, and then if you chose, say, Urdu or Pashto or something like that, then you'll get the right glyph variants for those languages. Hi folks, we had some technical difficulties with the recording and had to re-record the middle section. Sorry for the strange transition. Okay, so another thing that GSub is used for is getting the contextual forms, like in this case for Arabic. If you have be written in the middle of a run of joining characters, you need what's called the medial form. So for example, if we had 3 of these be in a row, the one in the middle would take this shape. So here we have the medial feature of the GSub table for the Arabic script, mapping this isolated glyph to this medial form of the glyph. Another related table is the Gpaws table, which is the glyph positioning table, which is used to get the relative positions of the glyphs to one another. One widely used form of this is for kerning. So here's a somewhat contrived example where I'm using all capitals to exaggerate see the exaggerated adjustment. Because between capital A and capital W and Y and an A, there's a big adjustment. So here on the top is without kerning, on the bottom we see it is kerned. And the way that works is through this kern feature in the Gpaws table. And in this example, you've got a P and an AE ligature, and the X advance has a negative adjustment to it to pull them closer together. So you can see the foot of this A is now coming under the curve of this P here, whereas before they were much more separate. So this can also be a positive advance. So if you need to prevent a collision of 2 glyphs, that X advance change can be positive to move them apart. Another thing Gpaws is used for is positioning diacritics over base glyphs. So in this case, we have that medial form of the be, and we're putting this fatatan glyph above it. And if you can see this little red point here, this is the attachment point where this diacritic is attaching to this medial be, and this is a form of mark positioning. There's also a form of mark-to-mark positioning, so if you're stacking diacritics above or below the base glyph, you can use that. So here it's the medial be. Here's a final be. You notice that whereas before it was above I'll call it the tooth of this medial be, now it's not above the tooth, it's above this curved part. So here you can see the red attachment point is a different place. So another use of Gpaws is for cursive positioning. So in this case, we're looking at a form of Arabic called nastaliq. It's a calligraphic style that's used in Iran and in India and Pakistan and Afghanistan. So Farsi, Urdu, Pashto all use this style. It's a beautiful style where instead of all the Arabic glyphs being laid out flat across the baseline, the connected runs form diagonals relative to the baseline. So on the left here, the word is Wikipedia, and several of the characters, the glyphs, are joined up along this diagonal. The way that works is, here's in the example here on the right, we have 3 dotless bes joining up. These little red points are where they're attaching. So here's an initial be, here's a medial be, and here's a final be. And these little red marks are the attachment points. So this is how the shaping engine knows to sort of stack them up vertically and connect them. And so over here on the left, this example on the top is what would happen if we didn't use this cursive positioning feature. All the pieces would sort of fall down to the baseline and no longer be joined upright and no longer form this beautiful diagonal that we see in the bottom where the feature has been applied. Related table is called the GDEF table or glyph definition table. I won't spend too much time on this, but just be aware that it's there. It specifies base glyphs and mark glyphs and ligature glyphs and that kind of thing. So it's just used in conjunction with the other 2 tables to help the shaping engine know what it's working with. Okay, so BiDi, I talked a little bit before about BiDi. When you have left to right and right to left text, you need to make sure they're rendered in the correct reading order. So the top line here is the order in which the characters occur, and the text buffer is the order in which the letters are typed. So I have salam and hello with an exclamation mark. So the shaping engine analyzes this, figures out that these first 4 characters are Arabic letters. This is a white space. This is an O and its other neutral, another white space. And then several Latin letters and another neutral from a directional point of view. And then it applies different rules from what's called the Unicode BiDi algorithm to decide how to resolve the neutrals. So in this case, because we're starting with Arabic, it's saying, okay, this is an Arabic line, so the space and the ampersand and this space are all going to be treated as right to left, which is this level 1, and then these characters for the Latin letters are being treated as level 2, which is going to be left to right. And this final punctuation, because it's essentially an Arabic sentence, is going to be right to left. So then you see they get reordered. So now salam is in the correct order, being read from right to left. The space and the ampersand and the space are still in the correct order. Hello is going left to right. And then the exclamation mark is at the Arabic end of the line. So this works in conjunction with yet another file from Unicode called the derived BiDi class is actually derived from some other data files, but it's all coming from data from Unicode is the point. And so here we can see the different categories, the white space for the Unicode space character, the other neutral for the punctuation, the left to right letter for the Latin, and then the Arabic letters for the Arabic letters. So if you're adding a new character for a right to left script, or actually if you're adding new characters, period, I mean, we need this data needs to be updated for any characters in your writing systems to make sure that the bidirectional bidirectional algorithm knows how to work with those letters. So yet another piece of data. So when you see a script proposal or a character encoding proposal go to Unicode, you'll see little sections for each of these files, like here's the new characters, here's their properties for these different files, and this is why those sections of the proposals are needed. So let me just give a little example of the BiDi and shaping that I just talked about, just to make it a little more visual. So one more file. There's an Arabic shaping file, which is what tells the shaping engine what the joining is for each of these characters. So here we see Aleph is right joining. Seen is dual joining. Lam and Mim are all dual joining. So when these are the Seen, Lam, Aleph, Mim. So because the Aleph is only right joining, we see it joins with the Lam but not with the Mim. So that's how this information is being used to figure out, for the shaping engine to figure out the joining. So now getting into the example, here's Salam. I haven't turned on the BiDi engine yet, so it's in the wrong order. Here's Seen, Lam, Aleph, Mim. That's wrong, it should be the other way. So I turn BiDi on, and now it's correct from right to left, Seen, Lam, Aleph, Mim. So I start turning on the different OpenType features. Here I've just turned on the initial form, so now we get this initial form of Seen. Turn on the medial form, so now we see the medial form of Lam. Turn on the terminal or final forms, which gives me the final form of Aleph. And then I finally turn on the ligatures, and now we've got the Lam Aleph ligature. So we've finally got Salam. Now all that happens like essentially automatically and in one step normally. I've just broken it down to kind of show what's happening behind the scenes, so you have some idea of what's going on there. So I think that's all I had for slides. So I just wanted to close with the point I opened with, which is if you get nothing else out of this, just keep in mind that characters are not the same as glyphs. The relationship isn't necessarily one-to-one. And so that there's a lot of work that needs to go on to making sure that you do get the right glyphs in the right order, in the right position, even after you've already encoded the characters in Unicode. So with that, let me open up for questions.
Chris, thank you so much. You have demystified everything. Now we understand, what's going on behind the scenes. I had no idea that it was so complicated, and of course, it makes absolutely sense. But now seeing it the way you presented it, and you made it so easy for us to understand. Thank you so much.
You're welcome.
I'm sure everybody has questions, but let me start with one. When you're building up something, you need linguists to help you how to write it, right? all
Yeah,
the
so if you're
details and the rules.
so if you're building a font or if you're building support in the software, you want to work with people who are experts in the writing system. Yes.
Any questions? Any comments? I think we're a little bit all, taking it all in. I have to watch it again.
Can I?
Yes, Siva.
It's really brilliant presentation. It's so lucid, so beautiful. In fact, now I'm tempted to learn Unicode after his listening to him. All this while I was under the impression that it's like Latin and Greek. Now it is very lucid, and I find it very, very interesting. And because it's a kind of a thing that one needs to learn, especially if one wants to work with indigenous communities, because the major languages are easier relatively now because the fonts are available, and whereas when we are trying to work with indigenous communities, I think that's where real challenges come. And of course, this is where we are in a dilemma whether we would like to use the dominant languages fonts for writing the indigenous scripts or invent something for them. Is something is a problematic issue. But I think now I'm very clear with your presentation, and it is so beautiful. In fact, I no, though I have in the very initial stages of my PhDs, I've learned a little bit of software for analysis, but after that I started feeling it's like Greek and Latin to me. But now it's very clear, and I think it's good. Maybe if some of us catch up with some of these ideas, it becomes easier for us to work with indigenous communities, because indigenous communities are each one has variations in their dialects. So how do we capture that is an important aspect. I think I catch some ideas from your presentation, but I think it's a very long way for us to go just to catch up to that. Thank you very much for presentation.
Thanks, Siva, for this. I think a lot of us feel this way. Tex has his hand up. Tex?
Hey, Chris. Great presentation. So, kind of following on to what Siva was saying, if we want to work with indigenous communities to create fonts for them, so first of all, it's amazing to me that fonts work, having seen all of the tables and data that's necessary, right? But working with an indigenous community, I don't think our group or the people in the community that might want to have a font would be able to create all of that. Is there a set of initial steps that we could tell an indigenous community, say, if you'd like to have a font, here is some basic data that the community would provide, which would then enable a font developer to create the font. So they're not going to provide all the data for the tables. Some of it, we can help with because we can provide the script tags and the language tags. But what would be a good first step, at least to bridge the gap between a community and its writing system and a font developer to be able to say, here's how we can start. It might not have everything, but we can at least get some basic writing in there. Do you have some suggestions for that? Because that's something then, if we could capture it and put it into a document or provide training to communities, we can then enable communities to start getting fonts, or maybe it's just not something that can be done. Yeah, how do we bridge that gap?
Yeah, so I would start with the Noto project for two reasons. One is it's open source and it's covering pretty much everything or almost everything that's been encoded in Unicode already. So the chances are pretty good that there is a font that is close to what you need. Let's talk about two scenarios. One is it's an existing writing system, and you're adding new characters, and then maybe you need to work in new ways. In that case, there's probably already a Noto font that covers that script, and it's just a matter of adding support for the new characters and the new glyph forms that go with them. So this is an open source project, so you can totally use that as a starting point. Scenario two, it's a completely new script that there isn't a Noto font for. There's probably one that's at least functionally close to what you need. So if it's an index script, there's probably a related index script for which there is a font. So you can use that as a template. Like, as I said, it's open source, so you can look at it, you can see how it works. Use that as a template for building up the new one. And then you could also try to get Google's Noto project to make a font for you and work with you on making the font. And I don't know if Craig's able to talk about that. I know Marek Zirek is the person I work with on the Noto project. So I think Craig or I could get you in touch with him. Craig, do you have any other things to add on the Noto side? Or
I asked the people on the Noto team about when they are going to be able to develop a new Noto font for a script that's newly added to the Unicode standard. I know generally for living languages, they are anticipating what's coming up in a new Unicode release and try to have that ready fairly quickly. That's really important because another constraint here is that some devices allow you to add fonts to your system. You can do that on a desktop or laptop, but many mobile devices either disallow it completely or make it very difficult to add fonts. So for a new release of a mobile operating system, it's important to get those new Unicode scripts into fonts as soon as possible.
Yeah, in some cases, though, for some of the communities we might be working with, they don't yet have a Unicode character set. So we also have to, we'd still like to start on a font, while the Unicode encoding process is in there. So I don't think, because this is a recording that's going to live on later, we need to name individuals, but the suggestion of identifying similar writing systems and going to the Noto project are good places to start. I think we need to provide a little bit more detailed guidance. Even the idea of how do you decide which other writing systems are similar enough can be difficult for some communities. But we'll take that as a starting point. We'll have to see if we can flesh out a few more steps to help communities get started and understand what to do. Thanks, Chris.
You're welcome.
I'll raise my hand. Am I next in the queue then?
Yes, Craig.
You showed 5 different components, Chris, of the whole process: shaping engine, the font, rasterizer, and so on. Those are not, and you gave examples of open source versions of those, but every company, I assume, could replace those with proprietary versions, or those things can vary among different platforms or operating systems, or maybe even different applications. Can you give me an idea what the variability is that one can expect between running on a particular operating system and a particular application versus a totally different environment?
Yes. So without going into too much detail, I would say every major platform does use different software for that stack. I mentioned Adobe is starting to use Harfbuzz as a shaping engine in our applications. But other parts of that stack we're using proprietary software for, and Microsoft has their own, Apple has their own, and so on. So the the reason I focus on the open source communities, I think if you're trying to, the open source projects, I think if you're trying to meet the needs of a minority community, the open source area is something where anyone can jump in and contribute and build support quickly. Corporations can move much more slowly than a motivated open source community can. Let me rephrase that. Corporations tend to move much more slowly than a motivated open source development team will move. So that's why I was calling those out. If you're trying to get support to a minority community, I think open source is the fastest way to get them support.
Mhm.
Yeah.
But well, I'm working with a couple of people who said that they are wanting to build fonts for new scripts that they want to introduce to their communities to decolonialize their languages. And these involve totally new shapes and totally new rules. But they often will find that even though it might, the shaping for their font and the presentation might work okay in a particular browser, when they try to use a word processing application on another operating system, it just totally fails. And it sounds like all these pieces need to be coordinated to get these things to work at all, and then working consistently is a big challenge.
Yeah, I mean, there are hacks you can do. I didn't get into it too much. I talked about default language, but there's also a default script. So if the shaping engine doesn't identify the script, for example, if it's in the private use area or Unicode or something, I believe in all cases it'll use default. I'm not 100% sure because I haven't seen everybody's source code and I haven't fully tested this, but I believe they'll try to use default. So one sort of workaround is to have default language, default script in the font, and then just build a lot of logic into the G-sub and Gpaws to do everything yourself rather than relying on the shaping engine to do some of the reordering and that kind of thing. I've seen that done for minority scripts in the past. It's not guaranteed because it's not specified, but it's something that's worth keeping in mind if you're trying to build something very quickly before there's software support for it. Just build a font. I'll also mention that I've been focusing here on G-sub, Gpaws, and GDEF. Apple has a table called MORCs and another table called KERCs. So MORCs is like G-sub and KERCs is like Gpaws. So it's MORX and KERX. The difference being that all the logic really is in those tables. It's not software logic plus font table logic. It's all in the font. So there's like state machines in the tables. So there, if you're on a platform that supports those MORCs and KERCs, you can have complete control. You can totally reorder things and do positioning and everything exactly the way you want. I believe HarfBuzz now supports those tables, MORCs and KERCs. They're Apple's tables, so anything from Apple will support them. I believe recent versions of HarfBuzz support them. I'm not 100% certain, but I'm pretty sure that's the case. So if you have an open source stack with HarfBuzz, I think you can use those there. And in that case, you have more control and more flexibility. That's not going to work on a Windows machine, though, because Windows uses the G-sub and Gpaws and GDEF and not MORCs and KERCs. So just something to be aware of as an alternative.
I have a question, Chris. When it's actually one question with two legs. So when you have a new script which goes through Unicode and gets approved, then it will be released at the next Unicode release. So the first leg of the question is, does this updating on all the companies, Microsoft and all the engines and all the other places where it needs to be updated, is that automatic? And the second leg of that question is, after a Unicode proposal is approved for a new script and fonts, what does the community need to do one by one? Where do they need to update it manually and physically? So there is a list of, they need to go to Microsoft, they need to do this, and so on.
Yeah, so we're getting into a level of detail. I would, if I'd known it, I would have put it into the slides. So there's a thing called the Universal Shaping Engine, which was developed at Microsoft, but which is being used on other platforms as well, including Harfbuzz. And again, I can't speak for Apple, but I think they may have this implemented in their stack as well. I'm not certain by any means. But the Universal Shaping Engine, the idea there was to be able to pick up updates from Unicode and have them working quickly and easily. So it uses those indic files I mentioned, like the positional the syllabic categories and the positional file, those two indic files I was talking about. It pulls in new versions of those when there's a release, and then it can just update at least any indic script that uses those. But I mean, I can't speak for all the companies in terms of when they're going to pick it up and when they're going to deploy it and that sort of thing. So I would just say that for new indic scripts or changes to existing indic scripts, there's that Universal Shaping Engine provides a faster path now for updates. But I can't speak for Microsoft or Apple or anyone else for how long it's going to take them to get it out there, or Google for that matter. Yeah.
So, Chris, my question was mostly for the, you showed us the Microsoft, database where it needs to be updated.
Yeah.
Is that automatically done, or do the communities need to go to them and say, we need to update this, there's a new script? I think it's a manual process in terms of someone has to go and physically update. It's not automatically, like, as far as I know, software driven or anything. But Microsoft is actively involved with the Unicode consortium, and I know they're aware of when new scripts get added and so on. So I can't speak for them, but I would think that they would be on top of that. But if you see it not getting added, then okay, thank you. That's the answer to my question. Thanks. Anybody else? Any more questions, comments?
I have one more question or comment. I don't know what it is. I see a lot of communities are using font hacks where they've taken a Latin font and just changed the shapes. And that's a perfectly reasonable way of doing things if you have your own computer. But it sounds like there are, your talk has helped me understand that there are more steps than just changing the codes from the code for the capital A to the new Unicode code point for a character that need to be done to make this all work. All these other .text files that you mentioned. So that leads me to my question. The things in the .text files, the Arabic shaping, and all of these other things, are those actually built into the shaping engine and the other components, or are they built, or can they be built into a font?
They are built into the shaping engine. So it essentially reads something in the build process, reads those text files, converts them into a binary form that can be stored in the software, so it can quickly look up the values that it needs.
So someone oh, go ahead.
Well, so that's what I was talking about, either using the default and OpenType or using Morks and Kirks from the Apple AAT tables. If you do that, you can, with the G7 and Gpaws, it's a lot of work to do that. With Morks and Kirks, it's easier to build that logic into the font. If you're trying to build a font before Unicode supports there, before the software supports there, Morks and Kirks is probably the easiest way to get all the logic in if you're running on something that supports it. With GSub, using default language, default script, and Gpaws, default language, default script, it's harder, but it's doable. I've seen people do that, where they just went to great pains to do a lot of substitutions to get things to order the way they wanted and position the way they wanted, and so on.
It does sound tricky. Even basically, like what code point in a font really represents letters versus neutral characters versus punctuation and so on. That is missing when someone's just hacked a font together.
Yeah.
Understand. Okay. Well, this really helps me appreciate all the pieces that go into this. It is quite amazing.
we all feel the same, that we want to know more. I mean, this is, you opened up a world for us here.
And I have one more question or comment. If one wants to learn how to do this, what are the, does one have to go to Jerry Leonidas's program at the University of Reading, or what are the resources for people to learn at least how to build their own fonts in ways that are going to be relatively portable?
So I personally would love to go to Jerry Leonidas's program. I haven't gone, so I think that'd be great if you have that option. I keep coming back to open source. There are a lot of open source font projects out there. There's the Noto family. There's Adobe's Source family. There's other ones, all up on GitHub. So those are great places to look at existing projects to see how they were constructed. So I come at this more from the engineering side, not the design side. I'm privileged to work with some wonderful typeface designers, but I don't do the design part myself. So that part I can't really talk too much about. I mean, definitely if you go to Jerry Leonidas's program at Reading, that would be a great way to get into that. In terms of other programs, I'll mention there's the Royal Academy of the Arts in The Hague has a type design program. We call it Type in Media. And then Amiens in France is a type design program. So if you want to study typeface design, those three, University of Reading in the UK, Royal Academy of Royal Academy of the Arts in The Hague. It's also called KABK is the acronym for it. And then Amiens in France. Those three programs are really good programs for typeface design. And there's, from the engineering side, there's a lot of active work on software projects related to building fonts. The Google has their own font tools repo. It's everyone's repo, I guess, but Google puts a lot of effort into that and supporting and developing that. The HarfPost project, also open source, a lot of people working on it. Our own Adobe Font Development Kit for OpenType is also open source. So a lot of these, sort of the engineering side is a lot of it's happening in the open source world, and the community is happy for people to be involved and contributing there. Yeah, I don't know how well I answer your question, but I think that's the best answer I can give right now.
Thank you. Thank you. This is very helpful.
And Siva has a question?
Yeah, I just wanted only a small other thing, because is there any self-learning kind of source where we could use it and then learn? Because the way you explained, it sounded to me that it is quite possible for people at this age of mine can still learn. I'm interested in that. That's what is there any self-learning materials available?
Yeah, there's a book I wish I had read at the beginning of my career called Fonts and Encodings. I believe it's Yanis Haramboulis. I can double check his name in a second.
I note down.
Yeah, let me just confirm his name. Let's see.
So that's another Greek with fonts.
Fonts and Encodings. Yeah, it says, I'll paste it in the chat here. The book is called Fonts and Encodings from Advanced Typography to Unicode and Everything in Between by Yanis Haramboulis, and I'll paste that if I can copy and paste this. Give me a second. I found that book like
you can just,
years into my career, and it's like, I really wish I'd read it earlier.
You can put it in the email. Or else,
So I would definitely recommend this one. Let me
you can put it in the email or this thing I can note down.
Let me just find the chat. Where did the chat go?
Oh, it's
Lower right.
lower right. Yeah, third icon.
Yeah.
From the right.
Third from the right. I see.
Something that
See,
looks like,
present now, raise hand, turn on
Oh, no,
camera.
no.
Total away, right side,
Oh, hang on. I think.
completely on the right
Sorry,
side.
my screen. When I went out of full screen, it moved off the screen. Now I see it. Sorry. All right, here's the chat. Let me paste this in here. All right, so that's the book. Fonts and Encodings. It's in the chat now. Fonts and Encodings from Advanced Typography to Unicode and Everything in Between by Yannis Haramboulos.
Paralambus.
Oh, sorry.
I'll bet it's Greek.
It is Greek, yes.
Thank you for the correction. So yeah, that's a really good one. I definitely recommend that one. And the Microsoft site that I mentioned earlier, I'll just paste that link to for the open type tables. At the top level. Oops, not that far. This is, let me paste this in. This is the link for the Microsoft OpenType spec. And so a lot of what I was talking about in terms of the tables is there, are there. And then if you,
yes. Mm-hmm.
Yeah. Then the Unicode data files, do a count for that. Unicode data files are here, and then I'll paste a link for the documents that explain them. They're called Unicode technical reports.
Oh yes.
So these Unicode technical reports explain what those data files mean and how to use and so on. So pretty much everything I showed, information that I'm talking about, is all in these places.
Thank you very much.
Oh, you're welcome.
Yeah.
Well, I have a new request on my Christmas list now for that book.
Okay.
Will it fit under a tree? That's the question. How thick?
It's a big book. It'll fit under a tree, but it is a big book.
Well, Chris, thank you so much for enlightening us and opening up a new world. You saw the reaction from all of us. We want to know more. So it has been an extremely enlightening and successful presentation. Thank you so much. And could we have more in the future?
Sure, I'm always happy to talk with you all. So.